Hey everyone, and welcome to today's Explainer. I am so incredibly thrilled to have you here because we are about to go on a truly grand topographical journey. India is a land of just absolute staggering contrasts. I mean, we're talking about a place where permanently snow-covered mountains literally touch the sky up in the north, while these lush tropical islands rise straight out of the vast ocean down in the south. Today, we're going to explore how these super dynamic landscapes were formed, what they actually look like on the ground, and exactly how they define the lives of over 1 billion people. So let's just dive right into it. To really wrap our heads around this region, we first need to get clear on what a subcontinent actually is. Basically, a subcontinent is a massive landmass that has its own totally distinct geographical identity, almost completely separated from the rest of the continent it's attached to. India, along with Pakistan, Nepal, Bhutan, and Bangladesh, makes up the Indian subcontinent. And what separates it from the rest of Asia? Well, it's a towering, massive wall of rock and ice that we know as the Himalayas. That mountain range effectively isolates the whole region, which is exactly what gives it such a unique climate and culture. Here is our game plan for today. We'll start with a unique geographical subcontinent, then move to the mighty northern mountains, followed by the fertile northern plains, then deserts and peninsular plateaus, and finally, coastal plains and islands. All right, kicking things off with Section 1, a unique geographical subcontinent. Think about the sheer scale of this place. It's perfectly enclosed by natural borders that create 5 distinct physical divisions. Up north, you've got those massive Himalayan ranges acting as a fortress wall. Then, if you trace the coastline, you have the Arabian Sea to the west, the Bay of Bengal to the east, and the vast Indian Ocean down to the south. It is, quite literally, a massive geographical unit entirely walled off by soaring mountains and deep oceans. Moving right along to Section 2, the mighty northern mountains. Okay, to really understand these mountains, we've got to do a little time traveling. Millions of years ago, the arrangement of the continents was completely different than what we know today. There was this shallow body of water called the Tethys Sea, and it sat right between 2 massive land blocks, Laurasia up north and Gondwanaland down south. Over time, the Indian tectonic plate actually broke off from Gondwanaland and just steadily drifted northwards right across that sea. Eventually, it collided with Eurasia, and all the sediments on the seabed were subjected to these unbelievably powerful compressional forces. So, when that Indian plate finally smashed into the Eurasian plate, those crushed seabed sediments were pushed up into the sky to form the mighty Himalayas. They're what we call young fold mountains. And get this, because the Indian plate is still pushing north at a rate of about 5 centimeters a year, the Himalayas are actually still rising. Yeah, by about 5 millimeters annually. The ground up there is literally still actively shaping itself. So how is this growing mountain range actually structured? Well, the Himalayas consist of 3 parallel ranges, and they decrease in height as you move south. First up is the Himadri, or Greater Himalayas. This is the highest range in the world. It's permanently covered in snow, and it features absolute giants like Mount Everest and Kanchenjunga. Just south of that is the Himachal Range, which is where you'll find famous hill stations like Shimla and Darjeeling. And finally, you have the lowest, most southern range called the Shivalik. Oh, and it's definitely worth mentioning the Karakoram Range just north of the Himalayas, too. That's where you'll find Mount Godwin-Austen, better known as K2, standing at a staggering 8,611 meters. Let's head down from the peaks into Section 3, the fertile northern plains. Now we're going to follow the ice melt right down the mountainsides, because the crucial thing to realize here is that those mountains directly create the plains below them. Glaciers high up in the peaks melt, giving birth to major river systems like the Indus, the Ganga, and the Brahmaputra. As these rivers come rushing down the slopes, they carry a ton of fine silt with them. When they finally hit the flatlands, the water slows down and it deposits this incredibly rich fertile soil called alluvium. Ultimately, these rivers join up and drain into the sea, forming massive deltas like the Sundarbans in the east. And fun fact, that delta happens to be the home of the famous Royal Bengal tiger. Because these rivers bring fresh deposits of alluvium year after year and provide constant, reliable water for irrigation, the Sutlej, Ganga, and Brahmaputra plains are just unbelievably fertile. Plus, this huge flat surface isn't just perfect for building roads and railways, it creates a highly favorable climate for round-the-year farming. As a result, this whole area has become the incredibly densely populated agricultural heartland of the subcontinent. Shifting gears now to Section 4, deserts and peninsular plateaus. When we use the word desert in India, we're actually talking about two totally different extremes. Over in the west, you have the Great Indian Desert or the Thar Desert. It is exactly what you picture. Hot, dry, completely sandy, experiencing intense heat with very little rainfall. Its most important river is the Luni, and even that is only seasonal. But way up in the north, we have Ladakh, which is a cold desert. Because it sits at such a high altitude, and because the Great Himalayan Range completely blocks any moisture-laden clouds, a phenomenon known as a rain shadow effect, Ladakh gets hit with freezing winters where temperatures can plummet to minus 40 degrees Celsius. Humans are incredibly resilient, though. Surviving in the Thar Desert requires real ingenuity. Take, for example, the Tanka. It's a specialized underground tank built to harvest and store every drop of precious rainwater for the dry periods. But human intervention actually goes way beyond just storing water. To combat the extreme scarcity, the government literally brought water from the river Satluj all the way out to the desert via the massive Indira Gandhi Canal. Thanks to that engineering marvel, farmers can now grow crops like wheat, mustard, and cotton in an area that would otherwise be totally barren. Heading further south from the northern plains, we run into the absolute oldest structure of the Indian subcontinent, the Peninsular Plateaus. This roughly triangular region is a huge, undulating surface made up of low hills and ancient volcanic rocks. Up in its northwest corner, it's bounded by the Aravalli Range. The Aravalli is actually an ancient fold mountain range that has just been heavily worn down by erosion over millions and millions of years. It's incredibly rich in minerals like copper, granite, and marble, and it actually serves a vital purpose by acting as a natural barrier that stops the Thar Desert from spreading any further east. To really map this out, imagine a line drawn right through the middle of this massive plateau by the river Narmada, slicing it neatly into two sections. North of the Narmada, you've got the Central Highlands, featuring major plateaus like Malwa and Chotanagpur, where the rivers flow north to join the Yamuna and the Ganga. Then, south of the Narmada, lies the vast Deccan Plateau. The Deccan is framed by the Western Ghats on one edge and the Eastern Ghats on the other, with massive rivers like the Godavari and Krishna flowing eastward across it to eventually drain into the Bay of Bengal. And that brings us to our final stop, Section 5, Coastal Plains and Islands. Right along the edges of the plateaus, hugging the sea, are the coastal plains. The western coastal plain is surprisingly narrow, running tightly between the Western Ghats and the Arabian Sea. It's full of beautiful estuaries and, most famously, the stunning inland backwaters of Kerala, known locally as Kyles, which are famously navigated by those beautiful traditional houseboats. The eastern coastal plain on the flip side is a lot wider. It stretches out between the Eastern Ghats and the Bay of Bengal, and it's well known for its massive, highly fertile river deltas and huge, sweeping lagoons like Chilika Lake. Let's head out into the open ocean now for our final geographical feature, the islands. Over in the Arabian Sea, we have Lakshadweep. This is an archipelago made up of 36 islands entirely formed by coral deposits. Because of that coral origin, they have a very low elevation and boast some incredibly beautiful reefs. Contrast that completely with the Andaman and Nicobar Islands over in the Bay of Bengal. These islands, which are neatly separated by what's called the 10-degree channel, are rugged, they're highly mountainous, and they are blanketed in thick, dense forests. And here's a wild piece of trivia for you about the Andaman and Nicobar Islands. Because they actually have a volcanic origin, they hide a pretty fiery secret: Barren Island. This right here is the only active volcano in the entire Indian subcontinent. Honestly, it's just a super dramatic reminder of the intense tectonic forces that shaped and are actively still shaping this entire part of the world. As we wrap up this grand topographical tour, I think this quote perfectly nails what we've been talking about. Unity and diversity begins with understanding our geography. Think about it for a second. The geography we just explored together isn't just a bunch of static rocks and dirt. The snow-capped Himalayas, the deeply fertile plains, the ancient plateaus, the extreme deserts, and the vibrant coasts. Every single one of these landscapes directly dictates the climate, the wildlife, the agriculture, and the rich, diverse cultures of the more than 1 billion people who call this unique subcontinent home. I want to leave you with one final thought before we go. We've traced this incredible, epic story of a drifting tectonic plate violently smashing into Asia, raising up mountain peaks that are literally still growing 5 millimeters every single year. The earth beneath our feet is entirely dynamic. Knowing that the Himalayas are still pushing upwards and major rivers are constantly shifting their paths, how do you think these dramatic landscapes are going to evolve over the next million years? It's a pretty amazing thing to ponder, right? Thank you so much for joining me on this explainer today. Keep on learning, and I'll catch you next time.